I welcome you all for the data structure class. So last class we've seen with what do you mean by binary search tree and operations. So today we'll see with how you are searching a binary search tree for a item. Suppose if you want to search any item in a tree, okay, whose value say assume x or k. Okay, so first what you do, if you are searching the element, first you visit the root node. Okay, if root node is null, then the tree contains no nodes at all, hence it is unsuccessful. Otherwise, if root node is not null, it will compare the value with the root node. If it is equal to that root node, then it says that key is found successfully terminated. Okay, if if the key value is lesser than the root node, then we go for the left side of the root tree. If key value is larger than the root node, then we go to the right side of the tree. Okay, so this is a general procedure for searching an item. Okay, we are having a function for it. What happens if root node is equal to null? Return root node. If item value is equal to root information, then you are returning root and item is found. Else if item value is less than the root information, then return search and you are going for the left link side. If item value is greater than the root node information, else part you are going there, you are returning search to what? Right side of the information, right side of the root node. This for one. If you go for the iteration way, how you are doing? First you are visiting the current node. Okay, if root node is equal to null, then it returns that tree is empty. Else current node is what? Root node. While current node is not equal to null, then what happens? Item you are checking with the current node value is matched, then you are returning current node. If not, then you move to the lesser than, you move to the left side. If it is larger than, you move to the right side. So this is the general procedure if you go through the iterative process. So this is for what? Searching operation. Next, for the inserting operation, first what you do, if you are want to insert a key, first we must need to check that the key should not be existing there. Okay, then once we do, then what we do, we create the node with the key value using the malloc function. Okay, next, if the tree is empty, what happens? Your initial key value will become the node of the first node of the tree. Okay, if not empty, then what happens? Then we go need to insert the created in the appropriate position in the tree. Okay, see here you are having example 150, 225 like this way. Okay, suppose I want to insert my new element is what? 140. First I will be checking my 140 to the 100. Okay, so here its value is greater than the 100, then it needs to move to the right side of the tree. So then it comes to what? 200. 140 is lesser, then it goes to left side of the 200, then it compares with what? 150. Again it is lesser than the 150, hence it moves to the left side, hence it is attached to the what? 140 to the left side of the root node. 150 node, you are attaching 140. So this is the procedure. How you can write the function? See here. Initially you have created the temporary node with using the malloc function. Okay, in the temporary node you are inserted the data. Okay, your temporary node left link r link value is null, you are not having anything, only node with the value you have created. Next, if initially you are having a root node is nothing, then you are returning the temporary node. If not, previous value is null, current value is what? Root node. Okay, this is the information initially. While if current value is root node value is not null, then what happens? You send previous values to the current value, then your item is equal to current information. Then what happens? You are printing that duplicate items are not allowed. Okay, if your inserted information is same, not allowed. If not, if item is lesser than the current node root node, then it moves to the left side. If larger, it moves to the right side. Okay, next, if you move to the right side, what happens? It will checking the information. If it is information, it moves to the left side, the temporary link, or right side. Okay, like this we will go on comparing each node, the information is inserted. Okay, so this is how you are performing insertion and search operation. So in the next video I will be uploading how you are deleting a node in the binary search tree. Okay, if you have any doubts, we can have interactive class so that we can clear your doubts. Okay, thank you.